Hey everybody, how you doing? This is Rich Ingalls with Seashore Comfort Solutions. I want to welcome you to the Seashore Comfort Solutions podcast. I guess I'm over here at the Streamography Studios with my good friend Andrew Castro. He runs the show over here at Streamography. So if you guys need anything with streaming or anything, definitely get in touch with them. There's a link in the description for his website. I just wanted to start out by saying, I appreciate Andrew for having me today. And, when we started the company, it was back in 2018. My wife and I were working with a big company on the North Shore in Massachusetts. And we eventually decided to say, now is the time to start our own company. So we, took a big leap and, basically spent a lot of money and got all of our stuff in order.
So much money, isn't it?
It was terrible.
So much money.
Terrible. But here we are now. This has been it's been 6 years, I guess. So it was December of 18 when we started it. So it's passed so fast. And it was tough when we first started because it was like we tried to figure out a way to get the word out and. So we eventually found the newspapers around Cape Ann and everything that actually generated a good amount of enough interest for us to start kind of getting our name out there, getting the trucks driving around Cape Ann, and that really kind of got us boosted, and then we've kind of gone from there. But
yeah, and if I can just kind of jump in there, Ringles, as far as that company up in the North Shore, that's where obviously we had met and worked together for 6, pushing 7 years.
Yeah, yep.
And for anyone that does listen to this and wants a little Easter egg, me and Rich used to do our own little show like this for the company up in North Shore.
Yeah.
That was fun. I was doing some graphics, I was doing some overlays, but
we were
nothing like the capabilities we got today, obviously.
We were getting some chats in there every once in a while with some of I don't think anyone really watched it, but there were a couple of the people in the office around that they would always jump in and give us a little bit of a chat, which was nice.
Yeah.
But I've been working around the North Shore since back in 1997. I started doing HVAC with a company out of Burlington, and eventually I got up into a company on the North Shore where I did a lot around Swampscott, Marblehead, and then even up into Cape Ann and down through Boston. So I got a lot of experience, commercial and residential, with a lot of those companies. I got to do Symphony Hall. I did Boston Symphony Hall for a couple of years with a company out of Lynn, where I got to see a lot of equipment that not a lot of people will ever get to see, as far as just some of the vintage equipment that's still running to this day
That's awesome.
without any issues because it's been maintained properly, stuff like that. But I think a lot of those experiences actually gave me the opportunity to learn in the field just on how these things work, because there isn't anyone out there that really knows. So you have to look at the stuff and actually try to figure it out. But when I started doing anything technical, I actually first started doing car audio. I did car audio systems.
Oh, yeah, I remember you telling me this. Yeah.
So I did a lot of show cars and stuff. I worked for Tweeter back in the day when they were a big company around here. And then I finally got to the point where I saw that, the car audio industry wasn't really going in the same direction as all these other industries, because, all the brand new cars were coming out with remote starts and they had good audio systems in them, stuff like that. So I just called a friend of mine out of the blue whose father owned an HVAC company and asked if they had any open positions. And he took me on, and I was making no money back in the day. I think it was like $10 an hour, $11 an hour when I first started.
Yeah, isn't that nuts?
Which is like, how are you going to survive on that? But
I think you'd be sued if you tried that today.
Yeah, right, exactly. But that was 97, so.
Was it because of your buddy that got you, like his dad owned the HVAC company? Was that the thought with HVAC?
Yeah.
Or why HVAC?
Well, a real good friend of mine was working for him at the time, and we were all friends and everything. So that kind of got me. It kind of drew me toward the HVAC industry, because I saw that my friend was making good money, and he's saying how many all these opportunities out there that you could grow relatively quick as long as as long as you know what you're doing and you can perform. So starting with them, I just kind of flourished from there. I started doing filters and belts and cleaning coils and stuff like that. So I'd go out to Connecticut for a couple of weeks and go from TJ Maxx to TJ Maxx and Marshalls to Marshalls. We did all of the TJX companies.
Yeah. I mean, dude, from day one, I've always said it to everyone, you're the mad scientist.
Yeah, well, it's like I love what I do, and it's like a lot of the companies and a lot of people that are out there that do HVAC, they know how to do this stuff, but they don't know the nuts and bolts and the actual science behind it and stuff. And I take a lot of pride in knowing how all of this stuff works, and that's a big thing for me, because it's like if you don't know what is really happening, how can you make it work correctly? You want to make sure it's running in the correct way that the engineers and the people that put these things together intended in the first place.
Yeah, yeah. We were talking about it like a little bit offline for a little bit, but how you geek out about when a system turns on, it does that ramp up, and then it finds like that
sweet spot.
Yeah.
Because a lot of the new machinery is all based on temperatures and pressures. So it's they want to certain machines they want to maintain exactly 108 degrees on the liquid line coming back. So the machine will ramp up and down until it finds that spot, and then it'll just kind of jog along, and maintain that temperature in the house. As the space temperature increases or decreases, it'll ramp itself up and ramp itself back down based on the load, because it's, back in the day, the machines, or even not too long ago, the machine would just turn on, run as hot as it could until the space temperature came down or went up, and shut off. And I equate it to, driving on the highway. It's like you're not going to floor it everywhere you go. You're just going to kind of rest your foot on the gas and cruise along. So just maintain your speed, maintain your temperature. You get to a little bit of a hill, you're going to have to get on the gas a little bit. You're going to have to increase the amount of energy you're using to increase or decrease the space temp. And so that's where the education to the customer comes in. Where
right.
A lot of these people don't know. Some people don't even know what they use to heat their house. They call in, and our customer reps will ask them what they have, and sometimes they'll be like, hey, what do we have for heating, honey, and what do we use to heat the house? And they don't know. So
does everyone still call everything a boiler?
a lot of people still call, they call boilers, they call furnaces. No, they call furnaces, but then they also call boilers furnaces.
Is that what it is? Yeah.
So it's.
I guess because it makes sense. Like they think like furnace heat.
Yeah, I think the confusion comes with way back in the day when people had coal-fired furnaces in their basement. They would go downstairs and shovel coal into a big cast iron furnace that just radiated heat. There was no duct work. Some of them had duct work but it didn't use a blower. It just used the gravity of the hot air rising to force the air up the duct. And then in main floors to second floors, they would just cut a hole in the floor and put one of those big cast iron grates in it to let the heat from the first floor go up to the second floor. There was no duct connections between the two.
Yeah.
And you still see houses like that to this day where they don't have any ducts going up to the second floor at all. They just have duct work on the first floor.
Right.
And then the vents in the ceiling of the first floor feed the heat to the second floor. So.
Yeah. How far we've come, especially with like the efficiency stuff you're talking about. Like you've always used that car analogy, which when I was working with you, that's actually when it clicked. That you're not flooring your car to get from downtown to the highway. You're just pressing on the pedal, and even when you get on the highway, you're just pressing it a little more. Just get to your speed and cruise.
Yeah, it's because if you're flooring it everywhere, it's the least efficient way to do it. You're wasting all the fuel or all the energy to get to someplace you could have got to in about the same amount of time, or maybe a little bit longer, but you're going to do it a lot more efficiently.
Yeah.
And that's the other thing is where when a lot of these houses had furnaces or boilers or whatever put in them back in 1970, 1980, in the mid to late 90s, those boilers then failed. People came in and they said, oh, okay, I need to change your furnace out. This is a 90,000 BTU furnace. I'm going to put a 90,000 BTU furnace back in. But the efficiency on the machines got better and better. So all of a sudden, a 90,000 BTU furnace, net, output is 87,000 BTUs. So then it's way too big to. It'll heat the house great, all the way down to 0 degrees, no problem. But you're wasting all that fuel that you didn't need to waste. Mm-hmm. And that's where, if you size these new machines correctly, you can heat the house efficiently and be comfortable at the same time. It's not hard. A lot of people were really scared about switching over to heat pumps in the first place. Because, a lot of people say, oh, well, you can't use a heat pump in the cold weather. It's, they don't heat good when it gets cold.
Right.
And it's like, well, if the heat pump is creating BTUs, then you just have to create enough BTUs to heat the house. You need a certain amount of BTUs to heat the house, just like you need BTUs to cool the house. That's where sizing them properly comes into play. And then you have to educate the customer as well, where, depending on the sizing of the machinery, some of the machinery might be way too big when it comes to cooling season. If you think about what the different outdoor temperatures, right? Summertime, 90 degrees. You want to make the space temperature 70. It's only a 20-degree gap. It's not huge. But if it's 0 outside and you want to make the house 70, it's a 70-degree gap. It's much more significant.
Yeah.
So if you size the heat pump based on the heating load, it's 3.5 times too big for the cooling load. So
it can handle.
You have to kind of manage it a little bit differently. So that's just something you have to educate the customer on when you go and do the sizing of the machinery in the first place.
And I had heard that from so many people that were just familiar with old school heat pumps and were just convinced that they couldn't handle it. But that is not the case anymore. Not
at all, no. And especially with the biggest thing was the changeover to the newer refrigerant, which is the 410A, where you can get a higher discharge temperature out of it, which would end up giving you higher air temperature. That's the big thing with heat pumps is the air temperature that it blows is not as hot as if you had a gas-fired furnace. Gas-fired furnace is going to be blowing air out at 140 degrees or so, usually 75 degrees above the space temp, so 140, 145. A heat pump is going to be blowing out at about 110, maybe 125 on a good day. So it's not going to heat as quickly, it's not going to feel as hot, but it is still heating. As long as it's creating BTUs and putting them into the space, we're still heating the space. As long as we're making enough BTUs to heat the space is going to be comfortable.
And if anyone can't tell, you love talking about this stuff.
Yeah, like I said, once you get me on a roll,
you just open right up about it. Yeah. And I think that's the thing that customers benefit by working with you and by working with Seashore, is that you will you're not a salesperson. You're a technician that just loves this stuff.
Right. I don't want to have a salesperson because I want to make sure the stuff gets sold to the people correctly. And a lot of these salespeople just want to sell you machinery. They don't care if their technicians have to keep coming back out and dealing with all of these problems and then in the future because they already sold the job and they got paid for it. So,
right.
So they don't care about the aftermath. I have to deal with the aftermath, so we want to make sure we put it all correctly, so then that way we don't have to deal with going back and fixing problems that should have been addressed in the first place.
Right. Callbacks, I remember, like we were talking about, when we worked together, callbacks when you got them. I remember it was almost like you took it personally as far as like, that had your stamp on it. It's like, all right. And you would go out personally. Right. I remember I think almost every callback, if you could, If I could, I would. And, and the issue is that, the technicians that are doing the stuff aren't trained
properly in the first place. They're shown how to put the stuff in,
Right.
and they know how it comes on and runs. But then all of a sudden, what happens when it doesn't work? Then
Right.
they have to start digging in and saying, okay, you need someone that knows what they're doing when it comes to service and repair.
Right.
You know?
And that's where, like, when you broke off and made Seashore, you were like, I'm going to do it my way. This is the way it's supposed to be done. And that's 6 years later.
6 years later, yeah, and people don't like reading install manuals and stuff, and that's kind of like what I do on my spare time, which is kind of lame, but it's like
Everyone's got a thing.
Everyone's got
Yeah, you know what I
thing.
mean?
But it's like I know how to put these things in, so if my
Right.
guys, when they're going to put them in, if they don't know something, I can instantly reference it, or I know it top of mind. But that's my biggest thing is, doing everything correctly. If you do it the way that the book tells you to do it, it usually works pretty good. If you put the book on the ground and kneel on so your knees don't get dirty, most likely the machine is not going to work pretty good.
Yeah.
So I'm
Yeah.
a big proponent. I'm a big fan of doing things correctly the first time.
Yeah. And that goes residential, that goes commercial, even some light industrial, you were kind of telling me beforehand.
Sure, yeah.
Depending on the project. But really your bread and butter at the current moment is residential and commercial.
Residential, commercial, yeah, rooftop units and commercial stuff. We do, rooftops from anywhere from 25 tons down to the smallest of the small. But most of our stuff is like between 10 and 25 tons regular rooftops. Some
Yeah.
industrial stuff.
We'll have to do an episode on, what that even means. The
Yeah,
tonnage,
yeah,
you know what I
as
mean?
far as,
Because
how many beats
I know you could spend a whole episode going technical on it, but I'm sure there's people that want to know the technical.
Yeah, and there's other stuff too that's going to be coming up really soon with the equipment manufacturers changing some equipment. There's a whole new type of refrigerant coming out. There's a change to the refrigerant. Back when I first started, we used to use R22. Then I think it was like 2008, we switched over to the newer refrigerant, which is R410A, the pink jug. And the new one is going to be called R454B, which is a mixture of two different refrigerants. I think it's R32 and R1234YZ. So they mix those two refrigerants together, and it comes up with a R454B. R410A is actually a mixture of R32 and there's another but the refrigerant that was bad is the one that they took out. So now they took the R32 and the 1234YZ and made it a better refrigerant. The ozone depletion potential is way lower. That's the biggest thing is
with the new one. Yeah.
with the new refrigerant.
Can I just make the naming convention is almost like Star Wars.
Oh, I know.
R2D2, R4, R10A. Yeah.
Yeah, it's like back when car refrigerant used to be R12. When people used to have R12 in their cars. Then they had R134A. They put that in the cars. Now they're putting the 1234YZ in the cars.
And so, we'll definitely have to do a whole episode on this. But
Easy.
the changeover, how dramatic is this change going to be implemented on businesses and homeowners?
It's not like an oh no type of thing.
Like you're forced on this date.
You sort of are. They couldn't import any more machinery that ran on R410A after December 31st of 2024. So no new 410A machinery can be imported. All the R410A machinery that's in stock and on American ground is still able to be sold all the way through December 31st of 2025. The equipment manufacturers are required to be able to maintain warranty parts and service for their machineries throughout the warranty period of those machines. So with Mitsubishi, we have a diamond contractor status, so we get a 12-year warranty on all our machinery through Mitsubishi. So on December 31st of 2025, if we install a machine, they still need to be able to warrant that machine for 12 years after that. So you figure in 2037, they're going to be able to back up machinery. They phased out R22. They started to phase it out in '08, and they stopped production of R22 last year.
Oh, wow. Okay.
But Mitsubishi still has replacement parts for their R22 machinery, plenty of parts for their R22 machinery to this day. So if you find a Mitsubishi machine that runs an R22 and you need a part for it, it's still available. So it's not like they're just saying today's the end date, you can't make any more stuff, you're not going to be able to fix your stuff anymore. They're still going to be making our 410A refrigerant, fresh stuff, but they're just decapacitizing the amount that they can make. So if they were making 800 tons of this particular refrigerant, next year they can only make 600 tons. I'm just throwing numbers.
It's a gradual, yeah. It's a gradual process.
And then eventually it'll just be phased out completely.
And this is for commercial or residential.
Commercial
That's the
or
same
residential.
process.
Yeah,
Like,
the machinery and stuff for commercial, I think might have a 1 year. It might be 1 year longer than the residential stuff, but it's
As far as
gonna
the
be
warranty?
yeah, no, as far as just a phase out of the machinery
okay.
stuff.
Yeah.
But it still has to be on American territory, and the
Right.
tariffs and stuff aren't going to affect the equipment that's already on the ground. So
Yeah.
nothing to worry about there.
Yeah. And if anyone has any questions about this stuff, could they reach out to you or the office, let's say? Like,
Yeah, if they call the office, they can definitely get good information from either Sarah or Julie there. But if Sarah or Julie aren't exactly sure on something specific as far as the refrigerant changeover stuff, then definitely reach out to me. You can get me right through the office as well. So just ask for me, and if I'm not there, I usually answer pretty quick if they forward it. But if not, I'll call you back.
yeah.
But yeah,
Really interesting stuff on how they're changing the dynamic of the equipment. And obviously, you being the mad scientist that you are, you're just up on top of it and already know all the logistics of it.
Yeah, I'm super optimistic for the new refrigerant as far as from the heat pump side, because we can make more heat than the existing refrigerant now. So, where we're getting that 125, 130 degree discharge air temp, with the new refrigerant, we might be able to get 145, 150, which would be, that's you're talking furnace discharge air temperature that's blowing out like a regular furnace. And that gives us more capacity control when we're talking about heating the space and cooling the space, because of that big gap, like I was talking about, the either 70 degrees or the 20 degree gap. It's going to change a lot. I'm super optimistic. A lot of people are nervous about it, but everyone was nervous about it when they changed over from 22 to 410A.
Right.
They were saying,
Right.
410A it's not as cold as 22, and I look at the chart and I say, well, at 34 degrees, it's still 34 degrees.
Right.
Right. If the temperature is the temperature, then it's not going to. It's still doing the same thing.
Right. Awesome. Yeah.
Yeah, that's my refrigerant bit.
Yeah.
I,
You could go into we could spend an hour. We could spend hours in here
Easy.
if we let you go off. But that's
Yeah.
why I know part of this, educational process. We actually want to bring on existing customers too. I think that would be really cool to just talk to some other customers and let them just speak for how awesome Seashore is.
Yeah, no, I'd love it.
And I guess what else about Seashore? I know you guys do commercial, residential, heat pumps, but then let's say someone else has just an existing units. You could service other existing units.
Oh yeah, sure. Yeah, if it's in a lot of our guys, my guy Dave is my number one guy. He's I've been working with him since 2005. Him and I have been doing he's been doing air conditioning since '05. I've been since '97, and I know I can trust him with anything. So if I say, okay, I need to go check out this particular unit, like not even just like a regular air conditioner. At some of these places, we do a machine shop that has these parts washers that use a chemical solvent to wash the parts. But as the parts get cleaned, the solvent evaporates. And then it gets kind of crazy, but around the outside of the machine, there are these evaporator coils, like air conditioning coils, that just sit there and get cold. So as the evaporated solvent comes up, it just gets attracted to the cold coils and sticks to the coils, turns back to a liquid, and then drains back down into the liquid tank.
Yeah.
But then there's
What?
2 layers of cold coils. One coil is cold. The next layer up is super cold. So if a lot of evaporated material comes up and it doesn't get stuck to the first coil, then it gets stuck to the second coil and gets drained back down into the tank. You can't actually see the condensation forming on the coils, but if you look into the bottom of the pans where the drain is, all of a sudden it's just all this liquid. And Dave knows how to work on these things.
Which is nuts.
Which is crazy. These things are the coolest things ever. But they have 4 or 5 of those machines, and they'll call in and say, "Hey, yeah, we got to send Dave over," and Dave is the only guy that we can send there.
Yeah.
So that's where it comes. It gets to be a little difficult, where we don't like to pick up way too many huge commercial customers with these very intricate machines, because we want to be able to focus on the people. If we're running around like crazy trying to fix 10 different problems, we're not going to be able to focus.
Right.
So we send Dave over there. He gets the day to do his stuff, and some of these machines are just super. I'd like to see if I can get some video of it so you can see how it actually works.
Oh, that'd be awesome.
It's just wicked cool.
Show the audience how it all works.
Yeah.
And even get some video of even just some normal units, like just some
regular rooftop.
Yeah, and just
like
show customers how it all works.
Yeah.
Like, here is what this thing is. We could spend an episode on. Here's the coil. Here's the.
And we even have some roofs. For the commercial stuff, again, we have some roofs that have old rooftop units. From somewhere like the 90s, early 2000s.
Yep.
To brand new machines. So and they're the same chassis machine. So it's we can look at this one and say this is what this looks like, and then we can look at this one and say this one looks different because it has a different type of blower on it. They made it more efficient by doing this, which is relatively easy to point out because they're big, so it's you just point to it on the camera and you're good to go.
Yeah. Awesome. I mean, if people can't tell, our whole goal with this is to educate and just be open about how this world works with HVAC.
Yep.
I feel like it's one of those things where people just turn on their thermostat and it just heats their home, or if it's summer, they just turn on the cooling, cools the home, and they just have no idea how anything else works.
Right. Yeah. And guys do the same thing when they go down into their basement and they're looking at their air conditioner or their heater, their furnace. If they notice something on the water heater, if they notice something just that we would normally notice, but the normal homeowner wouldn't.
Right.
They point it out to the homeowner and say, "Hey, you might want to get your plumber to take a peek at this," or they might refer our plumbing friends and
Right.
to them.
It's not like you have any skin in the game. You're not doing plumbing. You're just helping the homeowner.
Exactly, because it's
Right.
like you don't know what you're looking at when you go downstairs.
Right.
A lot of
Right.
homeowners don't. I'd say probably 50% of them don't know what they're looking at if they look up in their basement. Which is fine if it's not their thing, but make sure you have people that you do have in your pocket to come look at the stuff and make sure that it's operating properly.
Yeah. I can give a shout out to Ringles about my combi hot water system. Ringles personally oversaw the installation of that system.
And it still
And
runs.
it still runs. I've had it serviced, because that was 5-6 years ago.
Easy. Yeah. It's probably 14.
So I've had it serviced at least a couple of times at least.
Yep.
And dude, doing great. Heats,
Excellent.
combi, hot water, heat,
Yeah, and I don't
Ecobee
remember
thermostats.
did I size that? I don't remember if I sized it.
Yeah, you did.
Yeah, really?
Because you struggled with the first floor.
Trying to figure if we were doing like a 10-foot baseboard.
Yeah. I remember watching your
brain.
brain trying to crunch, like, how am I going to fit enough baseboard in here?
Yeah, because it comes down
conversation.
to footage.
Right.
I don't do boilers, everybody.
Yeah.
But
Oh, okay. Let's make sure to say that.
yeah,
You don't do boilers.
I don't do boilers anymore.
Okay.
With the previous company, we were an install company, so we did everything: plumbing, heating, air conditioning, all that
Yeah.
stuff.
Yep.
But we just do
Force hot
conditioning,
air.
heat
You do
pumps.
furnaces, air conditioners, heat pumps.
Furnaces, air conditioners, heat pumps.
Got it. Got it.
We're licensed to do refrigeration, but
Yeah.
we prefer not to because it's dirty and gross.
Yeah.
But with the baseboard, if you look at your baseboards, you could do it yourself, and each foot of fin tubing, each foot that has fins on it is, I think it's 580 BTUs at 180 degree water. So you could figure out how many BTUs you have on your first floor and first and second floor, stuff like
Yeah.
that.
Because I remember you saying how in one of the episodes you want to actually talk to customers about how, like, size your own home, give it a shot, see how close you can get,
Right.
and just so you understand what you're working with and how your heating system works and
Yeah.
how it functions with your home.
Yeah, there's a bunch. If anyone goes on Google, you can find easy load calcs and stuff. There's Cool
Yeah.
Calc. There's a couple different websites and everything where you can get pretty close. But I have a very specialized software that draws a complete 3D map of the entire space based on orientation. It sees windows, it sees doors. And within minutes, it can spit out a manual J, which is the actual load calculation of the house. What BTU requirement do I need to heat the house at X temperature? What BTU requirement do I need to cool the house at X temperature? All depending on where we are. So if we're in Gloucester has a degree day, which they consider to be, I think, 9 degrees in heating and 88 degrees in cooling. So when I size up our machines, we have to base it off of 9-degree outdoor temperature. We'll need this much heat to warm the house up to X.
Yeah.
But that software saves me hours. So
Yeah,
we'll
yeah,
definitely
yeah,
have
yeah.
to.
I remember that being
we
a
can do
crazy
a whole
process.
episode on that too.
Yeah.
I could do a whole manual J on this room in
Oh, that'd be funny.
10 minutes.
Yeah.
Yeah, pretty cool.
And then we could show the results right on the screen.
Yeah, right there.
Yeah. Sweet.
So that's
Anything else you want to touch on? I think we've been talking for a good bit here.
I don't even realize, but yeah, that's me. I've been doing this forever. It's the only thing I know. It's the only I love it. So
Yeah.
if anyone needs anything HVAC related, give me a call.
Yep.
SeashellComfortSolutions.com. And anything stream related, make sure you talk to Andrew Streamography.
Yeah. And if there's any specific topics, we'll be pumping out reels, we'll be pumping out all the short form video clips. I'm really hopeful that, if we can get some comments and feedback, like what do people want to hear about in this industry and in this world?
Yeah.
That'd be cool to get a little bit of feedback like that.
No, I'd love to. I'd love to see if we can get some traction, at
Right.
least a few people watching, and then,
Right.
get the word spread. If they see the clips on Facebook, and then maybe they'll start tuning into the podcast
long
every
form.
once in a while. Yeah, and
Right.
just take a peek and, even throw some questions to us so we can address in the next episode type of thing. Or,
Right.
Whatever it takes. I just want everyone to know what they're dealing with. I want people to know what's going on with rebates and everything. I know everyone's concerned about tax rebates, stuff like that. So
Right.
there's a whole lot of stuff that's changing, which is all positive things as far as I'm concerned. I see a lot of positivity when it comes to the output of these machines and what they're actually capable of. So I want to instill confidence in the people that these things can do it.
Right.
You got to do it right.
Right. Awesome.
Sweet.
Sweet. Thank you very much, Ringles.
Thanks for having me, man. I appreciate it.
Of course. To be continued.
Yes, sir.